In the last section, I left you with an activity inviting you to think through some of the separation technologies that might be used at a materials recovery facility to separate our commingled recycling stream coming into the different commodity fractions that get sent off to the end markets. In this video, I'll briefly introduce what are some of those separation technologies actually being used today, and you can see if you were right or not, or if you have anything that people aren't using yet. And then I'll link you some videos of actual facilities because it's always better just to see them working in practice. So just as a summary of what I'll show you, this kind of has all the groups of technologies that are presently used. And this applies both to our MRFs and it will also apply later when we talk about mixed waste processing and landfill mining and mechanical biological treatment. They'll all use similar equipment. And some of them we've seen already in terms of our organic waste treatment. So at the top of our list, trommels and screens. So just sorting things based on different sizes. We saw that with compost. We can also do that with our recycling. Manual separation by hand is the easiest thing and the oldest one. We can use electromagnetism properties. So we can use on steel, a normal electromagnet will work. Aluminum won't work with a normal electromagnet, but you can actually impose a magnetic field through aluminum with a device called an eddy current separator. So it works a little bit different than a magnet, but with similar principles. So that's how we can get our steel and aluminum. There's wet separation technologies. So this is what we saw with our wet AD treatment. Typically, you wouldn't use this for recycling because then you have to deal with all the moisture, but you might use this in MBT, which we'll talk about in this section later on. We've got air classifiers, suspending things in air and separating them based on density and size. Ballistic separation, it's a little bit similar to air classification. So throwing things and how their trajectory is changed based on density and size. And then lastly, optical separation, which actually uses sensors to sense colors and resin types of different materials. This is kind of our menu of things. And I'm briefly just going to show you what they look like before I get you to look at some videos of how they actually work in action. So in most automated MRFs, there's an order we apply these technologies in as well that you'll commonly see. And there are variations from facility to facility, but generally step 0 would be opening any bags that are bagged. Usually a system will ask you not to bag things, but some people always do. And to pull out any large items that are gonna impede the process later on, any films that are going to get wrapped up in the equipment. So usually this is a little bit of equipment and a little bit of manual. So now we've got a stream that's going to be able to go through the equipment. The first step is an initial size and shape sort, which will generate 3 fractions. One is a flat fraction with our cardboard and paper. One is a rolling fraction with our containers, and then also a small fraction, so any little bottle caps and broken glass and things like that. With multi-stream recycling, you wouldn't necessarily have to do this step to the same extent. So if you've got cardboard and containers separated already, then this step would be less important. From that step, there's additional sorts on each of those 3 fractions. So the paper and cardboard, you want to get the paper and cardboard separate. The containers, you want to separate the metals, the plastic, and the glass. And then the fines, you want to separate out the broken glass from the little bottle caps and things like that. So I'll show you some pictures of the equipment that does this, and then I'll get you into some real facilities to see what they're doing. So step 0, getting our bags open and our films out of there so they don't get wrapped up in the material later, is this type of equipment. So they kind of just have these spinning sharp blades that snag onto the films but don't snag onto the other materials. And that opens things up and sends everything that doesn't get caught up through. We've got our picking line or manual sorting. So you can imagine this would be a lot to do to all the recycling, but it can be effective in taking out priority items. And they'll either be what's called positive sorting. So that's removing what you want from the belt of material going by, or negative sorting, which is removing what you don't want from the belt. So if you're taking out contamination, that'd be an example of negative sorting. Now, in our initial size and shape sort, there's a few commonly applied technologies. So a ballistic separator, ballistic means like trajectory, right? So it throws things, and the things that roll will roll to the bottom, and the things that stay and our flat will come to the top. So that separates out our containers and our flat papers, and then the small stuff kind of falls through. A bouncing belt operates on similar technology, so it's kind of just throwing things, and things that can roll will roll down the belt. So the belt's rolling uphill, so the flat stuff will kind of stick on it and keep going. There are a few devices that exploit a correlation between what a material is made of and the size it is. So containers of a specific size tend to be of a specific material as well. So you can think pop cans are all about the same size, laundry, soap containers are about the same size. So wherever you choose that size, it will tend to be enriched in a different fraction of material. One of the materials that sorts based on size is a trommel. We've seen this for compost or dry digestate post-processing. So the small containers will fall out first and the big ones will come through to the end, and you'll have your big pieces of cardboard coming out the very end and stuff like that. Or there's a device called a screen. It uses these spinning stars or discs, and it will float some materials over the top, and then others will fall through. So once we've got our flat fraction or our big objects, which is mostly our big pieces of paper and cardboard, you want to separate out the paper and cardboard. A couple ways you can do that. You can use an error classifier. So that's using the density difference between paper and cardboard and kind of throwing them, and they'll fall into different places in the machine to get separated. There's a device called a paper spike, which sticks spikes through them, and cardboard will stick to them and then get pushed off, and paper will kind of fall off at the beginning. For our containers, you can similarly use an error classifier, so using the density differences of different materials. And there's a few different varieties of that technology. For metals are really easy to take out. So steel, the only thing a magnet will only target steel. So this is a really good way to get like high purity steel off the line. And there's a few different types of magnets. So there's a drum, a pulley, there's these overbelt magnets so they'll just kind of zoom the materials right off the conveyor. And aluminum will stay on because it's not magnetic, but you can apply a similar device, the eddy current device, which will throw off the aluminum. So where the magnet is pulling the steel on, the eddy current separator will actually repulse the aluminum. So in the picture, you can see the aluminum pieces just flying off the belt here, and then everything else will just fall out the bottom. If steel would go through this, it would react in a similar way, but it would also get really hot because it's more magnetically conductive. So you always have the magnet before the eddy current separator for that reason. And then you get the steel out and then the aluminum after that. Now that our paper and metals are off the line, our plastics are left, and we want to separate out to our different plastic grades. So you know the codes on the plastics, there's like 7 different kinds, and even within those, there's different colors you might want to separate. So it gets tricky. The technology that really leads the way for this step is the optical sorting technique. So there's actually sensors that will scan the material coming down the belt, and it will determine what resin type or color each individual object is, and it will have air jets timed for when that material is flying off the belt to give it a little puff of air and direct it so it actually arcs and then falls into the right bin downstream of the belt. And it's pretty amazing to see in action. You'll see it in the videos. Then our last fraction is our fines. So all our broken glass and bottle caps, we want to get that separated out into those different materials. One technique you can use to do this is a cyclone, which just separates on density. And we've seen this using water in our 80 pre-processing. So something similar to that, we'll get the heaviest glass stuff out the bottom. And then the other stuff will be separated. We've also seen it with air in some of the air classifiers you could use for your other containers. So that's just really quick kind of how that stuff works, but it's way more convincing to see it in action. So I'm going to link this video. This one does a really good job of walking through the process slowly and showing you each step. There's tons of these on YouTube, so I encourage you to find one for your local recycling plant as well. I'll post the one for Waterloo region, just so you can see what happens here in Waterloo. It doesn't follow it as detailed as this one, but it gives you an idea. So I'll have you go through that next just to see how all that stuff works, and then I'll see you soon.